This is Mr. Vector Fields. This is his child. We are going to demonstrate why Mr. Vector Fields is called Mr. Vector Fields. Just keep it up, keep it up. That was a demonstration of distance and direction. That was just me having fun. Poor Mr. Vector Fields. A vector quantity is an example of a vector that involves two important quantities. In order for a vector quantity to be labeled a vector quantity, it has to have distance and direction. So our example of distance was 5 feet. And our example of direction was south. Here is where Mr. Vector Fields were. We were standing exactly 5 feet away from this brick wall at our school. The reason it's called a vector quantity is because our distance was 5 feet and our direction was south towards the south wall. When we threw Mr. Vector, he ended up on the wall, thus creating a vector quantity with a noticeable direction. A vector quantity can be drawn out on a graph through many different examples. The only difference is the two spheres will never touch, but become mirror images of each other. Three examples of vector quantities are labeled as shown. Weight on a scale is a vector quantity because the person has mass and the pull of gravity, acting as its distance and direction. Throwing a balloon is an example of a vector quantity because it has distance and direction. Running a race is an example of a vector quantity because it is a measured distance and a given direction. A vector is labeled as a function because it can be defined on a graph. A weird example of a vector quantity is the example of wind on a pond. It's a weird example because wind can come from many different directions, and the wind's force can always change. We label this by showing more arrows. If the wind is calmer, the arrows will be longer and there will be less of them. If the wind is strong, there will be small arrows and there will be more of them. learned about vector quantities is that they affect many aspects of real life. Because they can always be defined on a graph, but that they can define things such as wind or throwing. They must always have two sets. They have to have distance or mass and direction. They must always be able to be defined on a graph. There can be an unlimited number of points depending on the difference in the mass or the distance.
Go.
And the final thing that we learned is Jenna really likes to throw water balloons.
Okay, and did you mail that to Christy or to me? Because I don't have it.
The making of Mr. Vector Fields and his kids.
That sounded really wrong.
Maybe this will be the first time it doesn't explode on us.
Possible, but unlikely.
Go catch a water balloon.
Okay, so am I drawing the face this time?
Go for it.
Awesome.
Do you want a towel?
Nah, I'm good.
Okay.
We'll make it. Make it work.
See, I thought we made half minus $1. Okay, so we owe $8.50 to $17.
All right.
Go.
Die!
I feel like it didn't die.
Let's do it again.
Take two.